Hello, everybody. Welcome to the Construction Record Podcast. I'm digital media editor Warren Frey, and with me today I have
Diana Lopez.
And Diana is a project manager at the University of British Columbia Sustainability Hub. She has contributed to multiple interdisciplinary research and knowledge dissemination projects and initiatives focused on sustainable buildings and urban development within UBC. She's got a Master of Applied Science and Civil Engineering from UBC. What we're here today to talk about is a report she worked on called the UBC Embodied Carbon Pilot Program. So to start with, Diana, could you tell us what that report is and what the purpose of it was?
Sure, yeah. Thank you for having me. The UBC Embodied Carbon Pilot was conducted by UBC's Sustainability Hub, and it was a multi-year research study on the practice of conducting life cycle assessments, or LCAs, for quantifying embodied carbon emissions from building materials. So basically, the objective of the pilot was to identify issues and solutions for enabling a more effective use of LCA in reducing embodied carbon on buildings, both on and off campus. And as you mentioned, the summary report basically is a summary of all the team's work over 3 years. It basically outlines our key findings and proposes actions to improve building LCA practice and basically leverage its full power for reducing embodied carbon in the built environment.
Okay, and what's the significance of embodied carbon in the building sector? I'm assuming it's pretty significant if you did a report on it.
Right, it is, yes. So buildings are significant contributors to the rising level of GHG emissions, which are basically causing our climate crisis. Operational energy consumptions and emissions have been reduced historically, and right now the embodied emissions from the building material choices are becoming proportionally more significant. So therefore, the importance of addressing embodied carbon in our buildings.
Mm-hmm. And how does that actually work? How do you reduce the embodied carbon in buildings and deal with the stuff that's already there?
Right. Yes, that's a great question. So embodied carbon is basically the GHG emissions attributed to materials, as opposed to the operational emissions that result from operating the building. So the embodied carbon can be calculated with an analytical technique that's called life cycle assessment, or LCA, which basically quantifies products' environmental impacts through its life cycle. This allows to estimate the building's overall embodied emissions from material production, but also from construction, repair, replacement, and decommissioning at the end of its service life. So it's throughout the whole useful life of that material and of that building.
And why study the entire life cycle, which I gather from talking to other people is sort of not a new, but a growing practice of looking at the entire life cycle.
Yes, correct. So we can look at materials from their whole life cycle, or we could also look at buildings so through whole building life cycle assessment. So whole building LCAs are becoming more common in green building programs and sustainability policies as a means to drive reductions in carbon emissions. However, these assessments are really complex. When you're talking about the whole building assessment, it's a really complex and data-intensive process, and it requires both the quantities of materials used in a given building and also an estimate of each material's environmental impact.
Okay.
Yeah, additionally to this, in order to develop effective emission reduction targets, these practices of conducting LCAs must be standardized. There are many variations in approaches to quantifying building materials and estimating their environmental impacts. And these variations make it very challenging to demonstrate that a building design has, in fact, achieved the desired level of emission reduction. So based on our findings, we created what we call a bill of materials generation methodology to start addressing the need for more detailed guidance to support the development of this consistent whole building LCAs that yield reliable results. And throughout the pilot, we were also able to gain a little bit of an understanding of the current state of LCA practice in the building industry and some of the challenges that need addressing through more effective policy.
What was the pilot study in particular about?
So the pilot study, we started with buildings that are on the UBC campus, just because it's easier for us to get information from those. So we conducted LCAs on numerous buildings, first on the UBC Vancouver and Okanagan campuses, and then from other buildings outside of the campus within British Columbia. We analyzed both the processes of conducting the LCAs as well as the results. So these buildings represent a range of functions, design, and material choices. We also conducted, in addition to conducting these LCAs on these buildings, we conducted literature review and policy reviews, as well as knowledge sharing sessions with industry practitioners and policymakers, and basically conducted a small pilot testing for LCA benchmarking as well. And as mentioned before, one of the key results from this project was the creation of the bill of materials generation methodology. And this guideline basically details and refines protocols to quantify building materials and to generate a building's bill of materials, which is basically a standardized list of the different materials and quantities in the building. The methodology defines a list of parameters that need to be determined before even starting to conduct the LCA, as well as some steps to create a detailed bill of materials of the building. And we found this to be a great gap. So through the bill of materials generation methodology, we try to address this gap as a first step to standardize the practice in the industry.
Okay, and how can construction in particular, I'm assuming other industries also can benefit from this, but how can construction in particular benefit from what you found in the study?
Yeah, so this pilot has the potential to improve practices of the use of LCA for embodied carbon in particular, but also for other impacts. And one of the goals of the pilot has been to share our learnings and experiences with the industry and beyond, providing valuable information to practitioners and also policymakers. So a very key topic here is policy. How can we improve policy to actually make an impact through life cycle assessment and actually reduce embodied carbon?
Okay, and this is a pretty big study. It's frankly pretty daunting sounding for all this info you have to go through. So who participated in the project besides yourselves, obviously?
Yeah, for sure. So we led the project for the 3 years that it was ongoing. One of our main project partners was Athena Sustainable Materials Institute. They were able to provide subject matter expertise and just consultancy in general to achieve better results and to guide our research and our processes. We also partnered with the Zero Emissions Building Exchange, who helped us as well with the promotion and with the outreach of all of these actions, and as well as sourcing data for some of the projects outside of the UBC campus. We also partner with NRCan, National Research Council Canada, through the LCA Squared initiative, as well as with our own UBC campus and community planning and the city of Vancouver. So it was a multi-stake project.
And can you explain the importance of material selection related to embodied carbon? Because I assume it's pretty important.
It is pretty important, yeah. So there's a wide variety of decisions that project teams can make when designing buildings. Whole building LCA is basically a tool that can help them weigh options and make decisions by measuring the impact of design choices. Most whole building LCA tools provide a breakdown of GHG emissions by material category so that you're able to analyze the results and inform decision making. So you get impacts from your wood components, but also from your concrete components, steel, glass, gypsum board, etc. Strategies for embodied carbon reduction, such as better material choices and material selection strategies, are what actually reduces the embodied carbon of a building. So we can measure it all you want with LCA, but if you don't actually change some of these decisions, you cannot actually reduce any embodied carbon. So some other strategies used to reduce embodied carbon include using less material in a building and selecting more durable materials that have lower replacement rates. And wood is a great material in that sense.
Okay, and mass timber is something that's getting adopted more and more, and it's on the Brock Commons is on the UBC campus. How did mass timber factor into all this?
So in this study in particular, we did use a lot of mass timber buildings, but we weren't exactly looking at how mass timber reduces or increases the embodied carbon. However, a lot of research is taking place to better understand carbon sequestration potential of mass timber and other materials. The life cycle and embodied carbon of products such as mass timber and its production is a work in progress, as well as developing a better understanding of how long wood remains in use. So those are also things that we're going to be looking at a later stage or in a further project, because we're very interested in answering some of those questions.
Okay, and for practitioners, what are some of the learning opportunities that they have when going through this process?
Yeah, so we got a summary of learnings in that report that we were referring to earlier. Basically, we got three big learnings. The first one was that there are multiple factors that affect consistency, reliability, and variability of whole building LCA results, which means these results are rarely comparable. And for this reason, it's important to determine the parameters for the assessment, such as the goal, the scope, the data sources, and the tool at the very beginning, ideally before even starting to collect the project data. So that was one of the learnings. Another one of the learnings was that there's a need for more standardization in regard to data collection and to LCA methodology and reporting and benchmarking. Right now, there are standards that we can use, but they are either not used for whole building LCAs, just for general material LCAs, and they're hard to adapt to whole building LCAs. So there is definitely a need in LCA practice and policy, and there is a gap for more standardization regarding that, so that we can leverage the full potential of embodied carbon, of LCA to reduce embodied carbon. And then the third learning is basically, in particular, creating the bill of materials, which is the key user input for the whole building LCA, requires a very structured process to facilitate the accuracy and comparability of results. And the proposed bill of materials generation methodology that we created through this project aims to address that need for a detailed guidance. So those are kind of the three key learnings, or at least two key learnings and one key outcome of the project.
Okay, and we already went through, I think, a couple of the major ways to reduce embodied carbon in buildings, but there are a few more besides that practitioners can go through as they're going through this process.
Yeah, sure. So there's a few. We touch up on some on another deliverable for this project, but I can kind of summarize some. So you can use less material in your building so that you're using, basically emitting less carbon by using less material. You can also design buildings that enable durability through adaptability so that it's less or expand the life cycle of the building and the useful life of the building. Rehabilitating existing buildings rather than building new. It has been proved that rehabilitating emits less carbon than actually demolishing and building a new building, because you're using all new materials instead of reusing the materials that you already have in place. You can also design systems and components for ease of maintenance to extend their useful life, or select materials with lower manufacturing emissions as well. Then there's also planning and designing for deconstruction and product capture for reuse at the end of the service life. And that's especially important for mass timber buildings because of the carbon sequestration potential. There's also substituting products with a low carbon version, and minimizing transportation and construction operational waste during construction. So those are kind of the main ones that we have identified.
Okay, and we've been talking about this report through this whole podcast. Where do people go to actually read the report for themselves?
Yeah, so we have a new Campus as a Living Lab website. You guys can go into www.livinglabs.ubc.ca. And there you can find a project page for the Embodied Carbon Pilot, where you can find a little bit more about the pilot and some resources, including this summary report.
Okay, great. Thanks so much for joining us today, Diana.
Yeah, no, thank you. Thank you for having me.